is. What it is AM radio signal emits a electromagnetic wave. That's how it works. So they just designed an instrument that basically senses where that electromagnetic wave is coming from. Kind of like a compass, if you want to think of it that way. It's basically just sensing that frequency or that electromagnetic wave. They're very, very susceptible to interference, especially if you have a storm. You start getting lightning, that needle just starts spinning and flipping, and because every time the lightning strikes, it's like, ooh, lightning bolt. Okay, a VOR doesn't do that because it operates on a very high frequency. Okay, but AM radio signals, that's why whenever you listen to 1160, it's all crackly and stuff like that. It's very susceptible to any sort of electromagnetic disturbance. Okay. So in our airplane, we do have our little ADF needles. Okay, and they are ADF needles. What does ADF stand for?
Automatic direction finder.
Okay, automatic direction finder. They basically point to the station. So we have our little blue needle, and it just points to the station. How do ours work?
Very well.
Are they NDB receivers? Okay, these are VOR ADF needles. A lot of people call them RMIs because traditionally an RMI was nothing more than an ADF mixed with a heading indicator. Well, what does RMI stand for? Radio magnetic indicator. Well, if mine is using VORs, is it using radio magnetic information? So correct terminology, if you really want to get into that, it's not an RMI because it's not sensing NDBs. If you call it an RMI, you're insinuating that it has the NDB capability. Does it make sense? Kind of, yes, no. So technicalities, but it has been actually a source of confusion with people because they, on a check ride, they were like, oh yeah, well I've got an RMI so I can pick up NDBs.
What do you call it then?
It's an ADF. It's a VOR ADF is what it is. So, and all it does, so these are really easy to read. The tail always tells me what?
Where you're at.
What radial I'm on. The head always tells me
Bearing to the station.
my bearing to the station, or in other words, a bearing to the station is nothing more than the heading that would take me directly to the station, or the course that would take me directly to the station. Okay? To fly, if I was to fly a bearing needle, okay, and we still do this so that they understand how they work. If I'm going to fly a bearing needle, I'm here and I want, let's see, where are we? I guess we'd have to change, let's put it up so we're a little bit more oriented.
What's that R stand for again?
Radial.
Yeah, I'm with
Sorry.
that.
Alright, so let's put the needle up. So there's where my needle is. And I actually want the needle to be pointing up right here. I want this number instead of this one. Where do I need to turn? To the left.
Yeah.
To the left of
Where you currently are.
the needle.
head.
Okay?
Oh, okay.
So the thing to remember is push the head, pull the tail. Just like a dog. Pull the tail, and they come up to sniff you, push their head. Okay?
You'll never forget that one.
Nope, there you go. Push the head, pull the tail. Here's what it means. If I am on this side of the head, it will continue to push it away farther from where my heading is. So in order to make this needle move over here, I would have to fly a heading over here to then push it that way. Now if you look at it, technically what you're also doing though is the tail is pulling towards your heading. So the tail will always pull towards your heading, the head will always push away from your heading. Now the rule is, to actually track it, is double the difference. Double the difference means that if I have a 10-degree difference between the head of my needle and where I want it to be, I'm going to use a 20-degree correction to push it over. If it's 30 degrees off, I'm going to use 60 degrees. Now the cool thing about these ADF needles that you're going to find as you use them is that they always tell you where you are. A VOR only gives you 10 degrees of deflection, right? This gives me 360 degrees of deflection. It tells me exactly where I'm at and how close I'm getting. So as I'm tracking in on a radial, I can watch that tail. If the tail's right here and I want it over here, I can see how fast it's moving. So I can increase my intercept angle if that needle's not moving very fast. Because my VOR is not going to come alive until 10 degrees. So this ADF becomes very useful to look at it and say, well, that's not even moving. Let's go for a 90-degree intercept. Watch that needle start coming in. Oh, it's almost to 10. Let's shallow back out to a 30-degree intercept. And so it really makes you a much more informed pilot, and you can really get onto your courses a lot quicker, know where you're at. Questions on that?
Just so I'm clear, it's picking up VOR signals.
Ours is a VOR,
You
yes.
can't do NDBs because
No.
it's okay.
Yep, we do not have the NV in it. I believe one of the Twin Stars, yes, no? I think one of the Twin Stars has an NDB in it.
You'd have to get a new receiver and an antenna is all, right?
Yeah.
And you could convert the Diamond Stars.
So yeah, you have to have the receiver. Oh,
Well,
that's something I
I have a
missed.
question.
Go ahead.
I thought I heard that we could tune it in as if it was an NDB, but it was really a GPS fix. Is that not
Yes.
true?
No, GPS is an acceptable substitute for VORs or NDBs
Okay.
using the OBS mode.
But would we still tune it in using the ADF stuff on the G1000?
No,
No? Okay.
no, you would simply tune it in as a fix.
Okay.
So if I had the Twila NDB, then all I would do is actually type in direct to the Twila NDB, and then I'll hit the OBS button, which the Katanas, the Garmin 430s have it too, where I can do OBS, and then I can use the GPS just like an OBS from that point. So yeah, we went up to Idaho Falls and they had us hold on a compass locator, and we had to do that. All right, I missed this, sorry, I'm bad. If you think about it then, if I have just a receiver, and I got my knob, okay? In my airplane, I literally have two separate units. I have a localizer receiver and a VOR receiver. They're two different units. They just so happen to be connected to the same display. So depending on which frequency I tune in, depends on which unit I'm using. The localizer is only connected to the needle. The VOR is connected to the needle and the knob because it actually gives me my range or where I'm at. Okay? So if you think of it that way, that's why a localizer doesn't care where you turn this card because it's not attached to it. It doesn't affect it at all. All right, where are we at? Oh, it's 12 o'clock already. Well, I guess we're done.
We could stay extra if you need.
Do you want to stay extra? They're like, heck no.
I got it.
He's like, I'm out of here. Okay. Oh, 12 o'clock. Okay, so next time we'll finish up with GPS.